Hi guys, Eric here. This is the second video in the Fusion Quick Start Guide series. On the first one, we learned how to import Fusion's network library into a fresh Unity project and how to start using it to run in client server mode, and also instantiate a character prefab and get the basics of the network library running. So in today's video, we're gonna focus on setting up a first-person shooter character controller and camera. So the goal here is to have a PC competitive grade or AAA grade, super snappy character controller that runs perfectly at any rendering rate you need. So if you have a 144 Hz monitor, even though you might be running the simulation at 60 Hz, or maybe if you want to be super competitive, 128, 120 Hz, this is all possible with Fusion. But you have that kind of super accurate control of the camera with a super nice mouse. So that's what this is all about. And another important thing here is that we're going to do this the right way. So the last thing we're going to do, for example, we're even going to include server-authoritative gun recoil. So because everything is going to be done with the authority loop, injecting input, running the simulation, snapping back to the simulation data that's, we know, server-authoritative, but can also do client-side prediction. And finally, accumulating the camera is going to be rendered accumulating on the rendering rate, so you will never miss any input, as small as it is, as fast as your monitor is, doesn't matter. Everything is going to be taken into consideration. So without further ado, let's get started. So I have here a project that's still very clean, but it has Fusion running on a scene, and we added here a prefab. It's not yet instantiated as a from a spawner script or something like that. But here, instead of using a networked transform as we did before, we're using another Fusion mono behavior called network character controller. So this will take care of the transform synchronization, but it will be very important because it is what you should use to actually have very accurate movements over the scene. So if we just make sure everything is running here and press play and run Fusion here, both server and client, actually nothing is yet going to happen because the character controller is not like a rigid body on Unity. So it does not actually do anything unless you have code that drives it. So it will only move, including gravity, if you keep calling in the simulation loop it to do so. So let's so to start doing this, I've already written here a small script to start to get us going a bit faster. But I'd like first to explain a little bit about the structure of this guy. So this guy is a regular Unity 3D capsule here, but it doesn't have a rigid body. As I said, it has a character controller. Everything is default. All the configuration here is the default one. And I included a small elongated box here to represent what would be, let's say, the arm of this character. And I made it as part of the character itself. So we're going to drag and drop this script here. I'm going to set it up with a small thing that I'm going to explain why. So I have a list of the renderers of this guy here. Of course, I could have this automated by getting from the children and everything, but I just manually set them here. The reason for this is that I want to change color of this guy, so we differentiate what we see that's coming from the server and what is actually coming from the client. So you see in different colors. And I'm going to now show the source code for this player controller script, and then we'll understand what it does. Actually, let's first run and see what happens. So We press play and we start server client here, and it didn't happen. So this is a live video, so things can go wrong. Let me make sure okay. No, yeah, that's not I just making sure I saved here to the prefab, but that's not the thing. So we have both behaviors here. Why is this guy not running? He should be running fine. So let's try again now and see if if it works. Yes, it does. Okay, so I think I just needed to touch the networked object script for it to rebake everything. So you notice that we have two colors here. I'm going to start again. So you see that we have one in front of the other, but that will be more clear when we start adding movement to it. But let's see a little bit about the script here, because it's very small for now and it's easy to understand. So I'm just going to cache a reference to the character controller. And I'm doing this from the spawned override. And another thing I'm doing here is I'm setting up the colors of the renderers, as I showed before, to be different, whereas if we're running on the client or on the server. So whenever we're seeing what's happening on the client, we're going to see it in red. Whenever we see it, what's going on the server, it's the green version of the guy. So we're doing this so we can see how prediction happens in the future on the client side. And the only thing I'm doing for now is I'm trying to move the character, but because I don't have any input, I don't have anything like that, it's still just going nowhere, but you already have gravity. So you have a lot of configuration options to do directly in the character controller itself here. So if you see config, so you can see here that have a lot of interesting things to play with, and one of them is like how much gravity you want to apply. So that's it for now. Let's now make this guy move based on input. So we know that we have to create our, I'll call it game input. We need to create a struct to represent our game input itself. I'm going to be copy and pasting some stuff because I've done this before. So to make things faster, I'm going to copy and paste from a different source I have here. But it will be straightforward to understand. So let me just copy the whole struct here, and I'm going to change its name to match game input that we are using here. So I'm going to call it game input, although if this will be a struct, not a problem. So this is very similar to the one that we were using before, and notice that we're storing a single 32-bit int to represent the binary buttons. And we have a weapon here that we're not going to be actually using for now, so this is not going to be part of this video yet. So, and we have an interesting type here called angle that I'm going to explain when we start using it. For now, we're not going to study it yet. So this is very similar to the one that we had on the previous video, but we have these two new properties that are going to be very important. So then, with an input struct done, we need to do two things now. So we need to actually spawn the character from the runner when the runner starts. We've done this on the first video, and we have to have an input script to actually be called to register the input from, to copy the input from Unity into this framework input. This is also registered in the runner. So our runner is here, and you see that our network events are all still all empty. And let me grab the pre-built scripts that we have here. Let me just make sure. That I check. So one thing we can just copy as it is our spawner behavior from the previous example is going to be, it can be the same. And I think our input can also be the same. I'm going to confirm here and then, yes, let me check. Okay, so except for this, we can reuse the same thing. Okay, let's just copy and paste and fix the compilation errors, because there will be a couple here. So see that our test input is a regular mono behavior, so we don't have this here yet. This will be added soon, and we know that we changed the name of the struct to be game input. Of course, I should have done a global replace here, but that's fine. So we have move and strafe, we have jump, and there's a crouch button here that we're not using yet, and there will be a button for fire. I'm gonna let this here be almost complete, except for the pitch and yaw camera controls, because I want to explain that in detail. But apart from that, it's all here. We also already have our spawner, so we can move back to Unity here and finish the setup of our runner. So let me make sure, yeah, everything's compiling. So we can now add both the test input and the spawner behavior to this guy, and see that we can now drag and drop our player prefab to be spawned here from the spawner code, and which means I can delete it from here. And we can now register both our on joined and on input methods to be called here. So we have test input here on input for the input callback, and we'll have I think it's the player joined, if I'm not mistaken, that we can call in our spawner behavior. What is wrong on connect player join? So let me remember how that's, where that's added. So oh, okay, sorry, I made a mistake here. So we're using a different approach here. So the spawner behavior, let me show the source code, is easier. So the spawner behavior doesn't need to hook to the events, because it actually uses the interface iPlayer joined, and it's just a regular simulation behavior that's already part of the runner game object. So when the runner is started, this is going to be called here because of the interface it implements. So I only needed to edit here. So let's make sure it's working, and that should be it. No, did I miss anything? Oh, we might need to rerun the. We might need to rerun the object table to make sure it's all clean here. Let's see if it's all fine now. Yes, okay. So we got our character controller spawned, although it's not I don't know why exactly, but it's not moving. So we got our spawn, we're fine. Why isn't this guy being called? Oh, okay, yeah, of course. So I'll explain what is wrong here, and then I'll show how to do it. So you see that the network object here only sees the network character controller as a network behavior here. it didn't consider there is some small quirks. We're still in alpha, right? So I apologize for that, but I needed to make sure, I just needed to click on this guy again so we will see these two here in this list. So it was only registering the player, the network character controller as a network behavior for this networked object. And sometimes you just need to touch on the prefab and you will actually register the other one. So let's see if it's running correctly now. We're spawning from the spawner and we already have input being collected. So yes, now it's all correct. So we see, but of course it's not moving yet. Why not? Why not? The thing is that we're collecting input from the input script that we have here, test input that's registered to collect input, but our player controller script is not doing anything with the input. So let's start doing that. So we'll go back to our player controller, and here's our fixed update. We have supposedly a move direction to fill. What is going to be this move direction? So I'm going to, in this case here, copy and paste here from the previous one I get. And let me get the whole, I'm going to have the whole thing here, and I'm going to delete, no, let me delete a few things first. Okay. And then I can copy here. Okay, this. So we need to clean the again the name of the struct itself, because we changed that. But we should have all these. So we have the forward, backwards, and right, and the jump being now consumed from the input that we expect to have registered there. So so see that we are also making use of the character controller jump default jump function and moving, but we're not yet rotating with the camera. That's going to be the next thing we're going to do, which is actually the tricky part. So if we just do this here, this is actually quite easy to do, but let's already start seeing what's going on. So okay, we can already see something interesting here happening. So the red renderer is the local client, and you can see that it goes slightly ahead of the server, because although we're in the same machine here and there's virtually no lag, but we can still see that the local prediction is always snappy to whatever is the movement that we are passing in to the server, and it's going to be like that. So the client side is always going to be smooth, well, whatever with the character controller or a network transform. But in case of a character controller, this is going to be fully client side prediction. Okay, so we have our movement loop, the base movement loop done. And now we're going to start actually adding a camera control. So we'll need to create a script for the camera. And there are a few important considerations here before we start. So here's the thing. In a first-person shooter, the camera orientation is authority of the client. So the client must have full control of where the camera is looking at, because that's the key for you to have a very, very accurate and fast response of the mouse movements. The position of the camera, though, is actually the position of the character. So the camera will actually snap to where the character is from the simulation. So what gets tricky is that you have to do the things in a certain sequence. So there's a very specific sequence in which things must happen for this to feel right, for you to get the PC competitive feel for this character controller. So what we're gonna do here is we're gonna use a lot of interesting fusion callbacks that will help you achieve this this kind of control. So first thing I'm gonna do is I will add a method in our let me check it here. So I'll make sure that we find our camera when the player is spawned. So whenever the character is spawned, I want to find my camera because I want to register that camera must follow myself as the character from the player in this instance of the game. So, and I'll also make sure we disable the camera on the server because we don't need two cameras in here in this case, and so I'll just make sure we have that. So I'll just copy a single script here. I'm gonna comment a couple of lines because we don't have the camera script itself, but I will for now add one single method call to our player controller here. So we see here what we're doing in fixed update network. So let's now add our scene loaded script, and it is this method, it comes if we make this guy implement iSceneLoaded here. I noticed that I forgot to add a utils method here for which is just a utils method to find the root of the scene of a certain runner, and because you might have more than one root objects in the scene. So I'll just copy and paste this script here and I'll show what it does. But what we're doing here is we're getting the Unity scene from the runner of this object, and then we're searching for the camera object in this guy. And we don't have yet this script, but we'll soon add it, and it will be what we need. I'm gonna replace it for camera for now, but this is not the reason why it's not compiling. It's because I added this as a helper. Then I'm gonna show here what it does. So it's quite easy to do. So it's called here scene utils, and I'm gonna show the source. It's quite easy to replicate. So it just gets the root game objects from the scene itself, from Unity, and it goes through them and find in the children the first result that contains the mono behavior that you are the kind of object you are searching for. It doesn't have to be mono behavior in this case, but normally you're doing this to search for something that has certain mono behavior. Okay, so because we're not yet using the camera script itself, it doesn't have these functions will not work. But we have a couple of interesting things here to comment. So because we're doing this when the Unity scene is finished loading, so this is a Fusion specific callback that's interesting to have on these behaviors, and it comes from this interface iSceneLoaded. And what we're doing here is, okay, let's get the camera I have on this particular machine. This could be server and client, and instead of using, hey, am I a client, am I a server, I'm actually being more specific here. What I'm checking is this machine the script is running now the machine that controls this object, controls this character? So do I have input authority, which means I control this character? If yes, this is the client side that has control of this player prefab. So I'm going to do something to this, which is I'm going to register the camera to follow this guy, and so on and so on. The other thing I do is, okay, no, if I don't have control of this guy, am I the server? Because the server never has control of a player itself, etc. If I don't have control of it, and I am the server, okay, I'm just gonna disable the camera itself. So this might be tricky on a listen server scenario, but in our case here, this is a quick way to disable the server camera. So I could have disabled the camera somewhere else, but let's first make sure this runs, and it will not change much here because we're not yet following the client with this, but at least we're gonna have only one camera here. So if we check here, you see from the scene root that the camera on the server has been disabled, and on the client side we still have the camera here. So that was the result we expected. So okay, let's move on. So for now, our player controller is just disabling the server camera. Let's now create a camera script itself that's gonna snap to where the character is, and which is gonna be the script that's gonna actually look for that is gonna check what the mouse does. So gonna go ahead and create a script called FPS camera. This one I'm not gonna copy the whole thing and explain. I'll just create one from scratch, and we will create it one line at a time. So let's make sure we have Fusion, and first thing I'm gonna do is this guy, yeah, it's gonna be a Fusion simulation behavior. And for now, I'm not gonna do a lot here, so I'm not gonna do many things at start yet. Actually, I will do something at start here. Let's start by adding these two references here. So I want to have a reference to who should I follow, and maybe I don't want to be snappy to the center of the object, but I want to have a certain offset to make sure I'm at the head or something. Of course, you could do this differently. Maybe you have animation going on and you have the head of the character, but in this case here, I'm just snapping myself to the main character with some offset. Also gonna this is gonna be important later, but I'm gonna add already, which is, let's make sure we don't see the cursor, because this is gonna be annoying when you start having an actual camera rotating. An interesting thing here, for now, we're not gonna do anything on updates. And you may think, okay, should the camera snap to the character? Normally, you do that at Unity's late updates. And although you could do here, the best way to do this is make use of the existing Fusion-specific callbacks, because those are going to give you more control of the sequence at which these things are running. So one interesting one here is called render. So render is guaranteed to be called after Fusion is updated, no matter if there's a new tick, no matter if there was prediction going on and server reconciliation, it doesn't matter. This is always the last thing to be called in the sequence of things in Fusion. So we're gonna do our thing from here. I think this is when I was still using late update here. We can check it if it will be possible to have a null here, but I think it's safer to leave it for now. But here's the important part. So if we have a target to follow, we'll just snap our position to be the target position plus the offset we're interested in. And then the interesting thing is that this guy, the FPS camera, is not going to be automatically part of the simulation, because it's not a network behavior unless we and it's not part of a networked object, so we need to manually register this camera to be called by Fusion, and that's one thing we're going to do from here. So this is one of the things I had commented here, so now we can actually do, and we fix this by actually finding local camera to be the script we're talking about, FPS camera, and then we can register this guy to be called from the runner. So that render method is going to be called and everything. So we're manually adding this guy to be part of the simulation. Remember, netcode is all about how you do the simulation. It's not about how you transfer data. So this guy is now registered. We just need to add this script to the camera, and we should have the camera snapping to where the character is. So let's get the FPS camera here, and let's try again. I forgot to add some offset, but we'll fix this later. No, it did not work. So what happened? Actually, the mouse cursor worked. So why didn't this work? Let's see if we forgot to do something here. So the camera has. Let's add some offset here anyway, because we need to fix this. So maybe that part of the code is not even being called, so scene loaded. This was supposed to have been called anyway, so let's make sure this is being called. I could debug, but I'll actually debug log only and see scene is loaded. This should have been called both on the client and server, so we should see two calls of this showing up. Let's see if it does. Otherwise, yes, yeah. So yeah, it is being called. So what did I do wrong here? So maybe, yeah, we do have input authority from the client side. That's for sure. So so our runner has input authority, and maybe I forgot to do input authority here. Maybe that's the reason why. That's one way to find out. If that's the case, it will be interesting, because it's something cool to fix. I'm suspecting maybe I forgot to do something here. So let's check if so this is called in two places. So one of them should have input authority, which is the client side, and the server side should not have input authority in this case. So let's see what shows in here. So okay, so server doesn't and client does have input authority. So we have one of them with input authority. So we should, oh yeah, we know this ran because we had the camera being assigned. So what is not being called here that I totally forgot? So have a simulation behavior being registered, and the simulation behavior itself has render. Maybe I forgot to add an interface to it. Supposedly this should work already. I'm gonna add the other interface that I need here, because we're gonna be needing this pretty soon. But we should not need to have this here to have our render. Oh! Did you guys notice what is wrong? Remember I had this check? So this call is being called. When I apologize so much if you guys noticed it and I just forgot. So oh, that's blame me. Sorry, I just forgot to set the reference to the target, of course. So unedited video. I'm sorry for wasting so much of your time on this, but let's get going. So yeah, here it is. We have our character moving. So see that this is because we're in a shared editor that's doing both client and server here. We only have one camera active. You remember that, but you can still see what's going on the client and on the server, right? But if you see, the red guy is super stable because the camera is just snapping to the client-side prediction. The server, we see it's slightly jumpy because this is network, right? So you get things to the server with some jitter, and the server simulates that. It doesn't matter. The server simulation is tick-based. And when the reconciliation comes back to the client, it's about a tick, and you always move forward again smoothly. So it's completely snappy, and it will still look smooth. So yeah, it's working. Let's move on and add the camera rotation now. So that's the important part. So the camera rotation on an FPS, you actually split into two different properties. So you do yaw and pitch. And the reason for this is that you want to actually apply the yaw, the rotation on the y-axis, to the character itself, because the character must must rotate itself based on the yaw. But the pitch, of course, visually you might want to have that on the head of the character, but you do not actually move the pitch of the whole character. That's, let's say, pretty much the camera and the aiming, and the head of the character. So we're going to split this into two different properties, and I'm going to copy and paste them here. So, and notice that they're private. These are not going to be networked. So these are local values that the camera accumulates. Notice that I'm using a type here called angle. So this is a special fusion type that's very, very accurate and lets you accumulate them without a lot of error. And it's also very good to be networked. So we're gonna do this very soon because this is gonna be part of our inputs. But for now, what matters is this. And one interesting thing is we need to, in the sequence of things, as I comment many times, the first thing we have to do in every Unity update here is to consume the hardware mouse movement and apply it to these yaw and pitch deltas. So this is also the reason why I'm using the Fusion-specific I before update here. Of course, you could consume this from the Unity update and making sure you had the camera script update being called before Fusion is updated. That would have the same result, but it's much cleaner and easier if you just do this. Have the I before update callback, and you consume the yaw and pitch from there. I'm gonna be very clean here and add a separate method for it, and call it from here. Yeah, you could have just made it internal here, but let's keep things clear, and that's accumulate yaw and pitch. I'm not yet gonna be sending this as input. I just want to see if the camera will rotate itself correctly, and so I want to. No, actually, I have to send that over the network already. So let's do the complete thing already. So that's better. So this is going to be called very frequently because this is going to happen every update, no matter if Fusion advances a tick or not. We're going to be consuming the mouse delta from the super fast rendering you have on your hardcore machine, whatever. And next time the input polar happens, we're gonna be consuming that. So here's what we do. So on every update, we accumulate the pitch in the yaw and the deltas of yaw and pitch here from mouse. And whenever the input polar is called from Fusion, we're going to consume the accumulated yaw and pitch deltas. So that's what this tuple here is what we're going to be returning, and we reset the deltas again because it's already part of the simulation. It's already there, so we don't have to keep accumulating it anymore. So this is the trick here, one of the tricks here. So where is this called from? So this should be called from the input callback itself. So So I'll do it in not in a less than ideal way here, but that's easy to do for now. So on the test input script we have, let's just have a private local camera. Oops, I'm sorry, caps. Let's have a private local camera variable here, the property here. And yeah, I could have used the same idea of scene loaded and so on, but I'm gonna be cheap here. I'm gonna be lazy here, and I'm just gonna copy and paste what I had before, and it will be fine. So we are already consuming the input from the movement buttons here, and what we're gonna do is we're gonna now include our camera yaw and pitch that we already have there. So see this here. So this is what I should have used the callback for, but I'm gonna leave it here for now. So I'm gonna grab the instance of my local camera this will only happen on the clients which have the input polar actually being called, and then I'm consuming the input yaw and pitch from the camera. That also resets the accumulated one. And if you guys didn't remember, our input itself already contains the same type angle to represent yaw and pitch to actually send to the server. So notice that this is going to be server authoritative. It's going to be part of the simulation. So we had a delta on the camera. We're sending angle yaw and pitch as input, and you soon see we'll also have a copy of this in the player controller itself. So you need this in 3 different places for this to work the way it should. So we had the camera generating this, we have the input consuming it from the camera, so we now need to have a copy of these guys on the simulation. And here's one cool thing, one important thing about it. On the camera, it's just local data. On input, is being sent to the server. We know, and it's also being it's going to be used. It's going to be used on the local prediction. But because this is supposed to be server authoritative, it should be server authoritative, of course. These are going to be networked properties on the character controller. So here's what that means. So on the player controller script, yaw and pitch are going to be the authoritative values for the rotation of the character y-axis and the look rotation on the pitch. So up and down if you want. So the last piece of the puzzle we need here is we need to consume now from input and apply that to the authoritative part of the network game state yaw and pitch on the player controller, and then we'll have the first part of our loop ready. So here inside the consume input part, we get copy from the input into the yaw and pitch, authoritative yaw and pitch that's part of the game state itself. So couple of things that I have to add here. So this is the simulation, and notice that for the character you only need the yaw, which is you're only going to rotate on the y-axis. That's already explained. So I add this here, so the character itself is going to rotate with the yaw. I don't want to test this until I have the full thing in, so I'm trying to explain as we go. So this is what we need for the character. Of course, to shoot you would also use the pitch, but that's another story. So I'm applying the yaw here. But then I'm now going to do the full loop on the camera so you guys see what we need. So on the camera, remember the render thing that we're using to actually snap the camera to the position of the character. Here's what we need on the camera. So you need to use the rotation of a stored in the character, because this makes it authoritative here, and you add that to the accumulated pitch here. So we're always snapping back to whatever the simulation has that fixes for server for reconciliation and so on. This is going to be super important on gun recoil. So we accept the server-authoritative value, which is the one stored in the player controller, both for pitch and yaw, but we also apply the local delta that was consumed before to make sure our camera is super snappy. So what do we do with this? So we're setting what the yaw and pitch are, and this is what we do with the camera itself. So after we snap the camera position to the character, we snap the camera rotation to be the pitch and yaw that we computed here. It's the loop back authoritative yaw and pitch from the character controller plus the local accumulated delta. So there is one last thing that I'm gonna test like this, and there will be one last thing we need to do that I'm omitting here for now. So let's play this and see what happens. So now we have actually camera pitch and yaw working, but there is something. Maybe the video is not going to be enough because it's only 60 Hertz. But there is something wrong here. It's almost complete, but there's something wrong, and I'm gonna explain what it is. So although the camera itself is moving very snappy with the local mouse, but still being corrected with the authority plus the local accumulated, the character yaw rotation is only using the server-authoritative one. So we're not applying what the camera accumulated on yaw back to the character. So that's the last piece of the puzzle that we're missing here. So if we pay attention here to our player controller, we are applying the server-authoritative rotation here. This is important because we're using the yaw, which is server-authoritative here. We need, so if you're gonna use the rotation of the character somewhere to actually shoot and not directly the yaw, which is another option, you need to be doing this so the server will on the next stick have the right rotation on the transform itself. I think this is a nice thing to do. But on the local client, we're gonna overhaul this because we wanna use yaw, but not only the server-authoritative plus client-side prediction yaw, we also want to have the local camera yaw. So what we're going to do is, this is the interesting thing. So we snap the camera to the position of the character, we snap the camera to the server-authoritative rotation that's stored on the character plus the local delta, and we apply this snappy predicted rotation also to the character again. And this only happens on the client-side prediction. This is going to be overhauled by the server reconciliation, but this yaw here makes it be super snappy on the client side. Also the hand, the gun. So this is the last piece of the puzzle here to have the full server-authoritative, client-side predicted, super snappy camera movement that works super well. So let's see how it goes. So you guys might not notice, but now the red thing is butter smooth. So it's by butter smooth I mean it's super snappy with the camera. And I have a nice mouse here, so it's super high res. So yeah, looks cool. I didn't test this before. We actually have jumps and all, so okay, cool. See, the green jitters, it's fine, but that's fine. What matters is our red thing is super snappy. That's what we see, what we get on our clients. And yeah, if we're seeing another person, it would also be very smooth. So this, guys, is the complete setup for the server-authoritative rotations, but with super snappy camera. So this is the right sequence. So let's just review what we did here. So the camera, so everything starts from the camera having before update being called. So this is the first thing being called. So it accumulates a local yaw and pitch super accurately on an angle. So it may, even if this is called twice because there is no new tick, and then another rendering update, super nice monitor at 144 Hertz, you get the accumulated one here. So this is the first thing that's done. Second thing that you get called in a normal loop would be the input. So input would consume input from here, and this input would consume the camera. This input would consume the camera yaw and pitch to send as input to the server and reset yaw and pitch here. So this second thing, it's already part of Fusion now as input. The third thing that happens then is the player controller. So the player controller then consumes the transfers, copies from the input into its local copies of yaw and pitch. I mean, it accumulates on its local copy of yaw and pitch, and then it uses whatever he has to apply movement and fixes its rotation. So you might ask why in this order here, the rotation, etc. Why am I moving the character controller without first applying the rotation? There is a reason for this. Normally you want the shots and the movement to happen with the previous stick orientation you had, and then you apply the rotation. But you might experiment with applying the rotation first and see what is correct. But from people I talked to, including lead architect Frederick, this is the right way to do. And even if you're shooting, it has the input rotation should be applied after shooting. So that's what he said. You guys might ask on the channel when we may discuss this, but this is what I learned how to do it. So that's it for now. So this is step. And then after this is all done, this includes client-side prediction, server reconciliation, and so on. Then the last thing that happens is the call from the camera render that finally consumes the server-authoritative and predicted pitch from the player controller, accumulates what was first accumulated in case this is not 0, and that's applied back to the camera itself, and then as yaw back to the character as well. So you have super snappy both camera and yaw of the character. There's one less cool thing to do, which is our recoil. So I'll just make sure I write down here the whole sequence. So so this is what part. So this is one, which is get data from hardware, and accumulate here. This might happen. This is super high frequency, so this can happen in a frequency that's higher than the frame rate, than the update rate of the game, the simulation rate, 60 Hertz. This is one. Second is this. So 2 is called from input polar. Always happens after that one is called, even on a tick where that's called, where we're gonna have a new tick. It's guaranteed that the before update is gonna be called first. So we consume input from the hardware, then we reset and consume this input and apply it and send it to the network. So this consume yaw and pitch is called from the test input, you guys remember. Then the third thing that happens is this, which is, it happens for local prediction, it happens on the server side when the input arrives to the server, but this is, in this logical sequence, this is copy from input into authoritative and predicted logic, which is the to authoritative and predicted state. So this is the authoritative game state for the character itself. This is number 3. And number 4 and last is we snap and apply back everything to the camera. So this is the render. So 4 apply back from state to camera plus local accumulated deltas. Don't forget also snap local player yaw to the same. So this is the full loop. Now let's the cream on the cherry on top is going to be server-authoritative gun recoil. So to do that, let's do something cool here, which is we're going to have a shoot thing, and to have a shooting logic, we need something like a cooldown. A cooldown would be better done with ticks, because ticks are nicer to transfer because it's an int than a float. But I'm gonna just use a float here for now, and it will be fine. It's for demo purposes. It just adds too much data because floats are more difficult to transfer than ints. But so if you can do this with ticks, is better. But here it is. So we're gonna have a server-authoritative part of the state cooldown because we also want it to be client-side predicted because we're gonna shoot immediately. And yeah, I don't want to shoot every tick if I have the button pressed for the shoot. If you guys remember, we have here something to represent a fire, and on our inputs we're doing that when we press the mouse button here. So the left mouse button, that's fire. Then we consume that. We're going to consume that from the player controller. So I'm not sending the mouse event. I'm actually just saying what is the current state. Is it pressed or not? So I'm always going to shoot if my gun can. So if I have that boolean true. So we have to control with the cooldown to make sure that the gun doesn't fire many times. So you guys may want to control this differently, but this is how I did here. In this case, this is a demo. So but here's what I'm gonna do, and look at how easy this is. So here, after we jump, whatever, we accumulated our yaw and pitch, then we're gonna shoot default. It doesn't really matter. Made a mistake here, so let me copy the right thing. So let me delete this here. So to represent a fire, we consume the button, and our cooldown must be smaller than 0. So we need somewhere to actually have both on prediction and on the server-authoritative logic. We need a line of code here to actually consume our cooldown. So we make sure that our cooldown lets us fire. And so if we have the mouse button pressed and a cooldown is smaller than 0, we can shoot, fine. And I'm resetting the cooldown to be half a second, just as an example here. It could be different. But here's the cool thing. You fire your projectile. I'm not demoing that here. What I'm demoing is how do you do a gun recoil. That's it. This single line of code here is applying gun recoil. And notice that this is server-authoritative. So your gun is recoiling and your character is going to pitch up. So you're going to have this on the server logic. So on the next tick, on the next shot, this pitch is going to be there unless the guy apply the delta on the mouse to fix for this pitch up. The pitch is inverted, right? So, but this is a pitch up. So let's test this. Let's see what happens here. This is the last thing I'm gonna do before we end the video. So let's see what happens here. So here's our pitch, and I'm just rotating, but I'm gonna have it locked here, and I'm gonna press the mouse button once now. See what happened? So if I keep, I'll do like 2 or 3. So 1, 2, 3. This is the pitch up. done from the gun recoil. So let me try something here. I'm gonna keep the mouse button pressed, and I'll have to keep compensating because it will just keep shooting up every half a second. So this is it. So I have to now keep compensating back down because our gun is shooting all the time. So this is server-authoritative gun recoil. Well, this is what I wanted to show in this video. Hope this is useful, and see you on the next one.